From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
About a year and a half back, I got introduced to this, I think they won't mind me putting their name out there, Volunteer Aerospace out of Knoxville, Tennessee. A shout out to them to, being an early adopter and a visionary in this, that they wanted a process monitoring system. And he handed me a industrial optical camera and said, look, if you can just give me layer by layer pictures, a good high resolution pictures, that'll be a win in itself. I don't even, at this point need a AI to tell me anything. I said, can do that and can do a lot more than that. So that was very useful and very helpful because we were able to collect data, we were able to get started.
That was SK. SK is the founder of Addiguru. Addiguru is an artificial intelligence-based real-time monitoring solution that aims to significantly improve the defect detection rate for the additive manufacturing of parts. He has significant experience in product management, strategic planning, product launches, and working with cross-functional teams. He joins the show today to speak about in-situ monitoring for 3D printing, both the challenges and the opportunities. SK also brings his perspective on starting a business just before the pandemic. SK, welcome to the show. Why don't we get started with telling the audience a little bit about how you got into the additive manufacturing space and specifically how did the idea for your company start?
Sure. Mike, thanks for having me here. Really excited to be in this podcast. Additive manufacturing is layer by layer joining of these layers together, right? So I actually have a lot of experience in welding and joining technologies, doing predictive analysis for that. I worked at EWI for many years, from 2000 to 2009. I had a medical device startup soon after that, in which we used additive manufacturing for our prototype parts. And, so I've been involved or known much about this industry all through my career. And, so I came across this idea of starting a company to do real-time monitoring of additive manufacturing processes a couple of years ago. Where one of my mentors, Dr. Suresh Babu, he's at Oak Ridge National Labs and University of Tennessee, Knoxville, and he's at the National Science Foundation and the National Science Board as well now. So we were chatting, and he brought up that hey, the industry really needs a practical and affordable solution, and you have a lot of experience and entrepreneurial skills. Are you interested in something like this? And I looked at it, then I, really started digging into it and realized there's a huge need in the market. And I went to a couple of conferences, talked to quite a few people, realized a lot of people are working on it, but a lot of work that is also going on has been going on in the direction which will take a long time to come to fruition, whereas the need of the market was imminent. So that's where I realized we could create a very affordable and practical solution and go after the low-hanging fruit and help the industry. And that's why I started this company in 2019.
And so let's kind of dive right into it. So what does Adiguru do? What specifically does the software do?
Yeah, so Addiguru, overall as a company, our goal is to do real-time monitoring for additive manufacturing processes. We are creating it as a platform technology where it's not just focused on one process, but it helps the different processes. And the idea is to use sensor data like camera, optical sensors, infrared sensors, gas flow sensors, and other sensors combined with deep learning, artificial intelligence, physics-based modeling, and obviously our process insight and material science knowledge, and bring it all together to identify these defects real time, like within 1 second of when a defect occurs. And that can be very powerful in the long run, right? So that's what we are doing. And we started with the DMLS process, or direct metal laser sintering process first, for various reasons. One, the value of a solution like this will be very high to that. And then soon we started getting a lot of pull from the market about FDM process. And the value per machine is lower of something like this, but the volume is very high there. So we are now addressing FDM as well, using optical cameras first. And then our next step is to include other types of sensor data and bring it all together. And obviously, then we'll go after other DED processes, plastic SLS processes, and bioprinting and other things as well.
And so the idea is that if you can capture some sort of defect, define it with the camera and the vision system, and then future other sensors, you have this kind of target range that the printer can operate then. And if something happens, you're the first to know. You are able to then notify the machine, notify the operator. What's kind of the action that would be taken after? Kind of
Yes. So yeah, I definitely missed that, right? So that's the whole idea, is that as soon as your defect is identified, it notifies the user that something's wrong. And as you're more like based on depending on the defect identified, it can really ping the user in a certain way and help them take an action. And in the long run, as the accuracy of our defect detection increases, and if there's a possibility of interfacing with the machine to do a closed loop, you can take certain actions like pausing machine. For example, if recorder streaking is occurring and software is more than 99% confident that it's happening, it can send a message to the machine to just pause it, and also send a message to the user saying the machine's paused because recorder streaking is happening. Your recorder might be getting damaged, so you might want to take a look real quick. That way, it could really help the machine and the user, right? So those are some scenarios. But yeah, obviously, closed loop is what the industry wants in the long run. But what I call closed loop is like self-driving cars. It's been promised to us for many years, but we haven't gotten it yet. So we'll get there. But could we just get a car to be driven on a highway by the AI? And can we get there first and go one step at a time? And that's what we are trying to do.
I imagine too, as you start to work with industry, you probably see a wide range of users who are ready to adopt this sort of technology. I imagine they need to have some sort of understanding of their process and what DMLS is, or FDM to a lesser extent is probably more understood than DMLS in terms of just operating the machines and having tacit knowledge of designs and things like that. But as you get further into your analysis and the value that your software is creating, what do you hear from users as kind of other benefits that you would be able to provide by having some of this knowledge of kind of where defects might occur or when they might likely occur?
Yeah, I think one is an immediate advantage, right? You stop a failed print sooner rather than later, and you obviously save a lot of time on the machine. You save a lot of money for the material as well as other aspects.
Right.
You can save a machine from getting damaged.
Titanium build's going to cost $7,000 or something to run. So if you are able to stop in the first few layers, that's real. Pay for itself, right?
And then also, you generally sometimes won't even know till it's gone for CT scanning that there's something wrong, right? So could you also save that money? So that is one aspect. The other is, you're absolutely right. It provides you more insights. It learns. It increases your learning of what's going on in the process. You can also, if there is some failure that's happening, you will also see what is happening, and you can also correct it much better rather than it being, something failed and you're guessing. The guesswork will be eliminated. And that will further improve the parameter development and the speed of, just overall efficiency will increase.
And as you've kind of developed the concept and kind of the understanding of the processes, what are some challenges that kind of you didn't expect to kind of overcome as you first kind of started this company and kind of getting the software out and moving along?
Well, the challenges are a typical startup challenge, and then on top of that, it turned out to be, when I started the company was in 2019, economy was doing really well. So it was one of the best times to start a company. It certainly in March, it turned out to be one of the worst times to have a startup company, especially if you haven't paid anything to yourself or any of employees in 2019, because you couldn't even take advantage of all these PPP loans and others that were out there. So yeah, it was a challenge, but challenges sometimes bring opportunities as well. One is I was able to hire good talent for not paying a lot of money. Another is I was able to bring in some talent, which, if not for pandemic, they would not have been available. So there's a silver lining to it as well. But yeah, obviously pandemic is a challenge, but other challenges are, how do you collect data? That is a big problem. And because these are $500,000 or more machines, right? So you have to collect data, then you have to analyze data. So that is a big cycle that you want to get inserted in. Once you're in, then you can keep collecting data and keep improving it. And that's why we designed the software so that we are dynamic. We are ingesting data in our software every month, and we are putting out our improved models every month, so that our customers can get incremental benefit right away, rather than having to wait 3 months or 6 months or just a one-time release of a software.
And when you're doing some of this testing and at different sites, do you ever purpose, like if you're doing a DMLS build and on a metal, and would you ever kind of purposely put in defects into parts to see that that the software works?
Yes. So till date, we have not done those kind of builds yet, but we got a couple of research awards, and part of those research awards will be that we'll be putting defects,
breaking some stuff,
but deliberately, right, so that we can see the data, we can get the data and correlate the data. But we have some access to some data where I'm working with some companies who have been, really interested. They've been early adopters, so very thankful to them, and hopefully we are bringing a lot of value to them as well. So yeah, as our algorithm, they give us more data, we train our models, and it helps them as well, right? So there is but yeah. So to answer your question, is deliberately putting defects will be happening soon.
Awesome. And so tell me how, so you've got this company, you started it kind of late 2019, and what were the first conversations like with some of your early partners and getting people to try and test it? What was your approach to convincing them hey, you should work with this guy and he's got some cool stuff to offer? Give me a little insight on that.
Yeah, it's funny. It's reminding me of about a year and a half back. I got introduced to this. I think they won't mind me putting their name out there. Volunteer Aerospace out of Knoxville, Tennessee. A shout out to them to being an early adopter and a visionary in this. That they wanted a process monitoring system, and he handed me a industrial optical camera and said, "Look, if you can just give me layer by layer pictures, a good high resolution pictures, that'll be a win in itself. I don't even, at this point need a AI to tell me anything." I said, "Can do that and can do a lot more than that." So that was very useful and very helpful, because we were able to collect data. We were able to get started. Getting started is very important in a startup, because if you are just struggling to get started, you don't find a way to go to the next level. So definitely that was very helpful, and hopefully we have been able to provide them, with a lot of value. So that was our starting story. That there was first time when I was collecting pictures. I had put a camera on and I was clicking by mouse myself after every layer to collect the right picture. And then now we have developed an intelligent imaging system where AI and computer vision uses and collects a picture on its own whenever the recorder moves. The right pictures at the right times are collected, and our AI is now detecting issues in the powder bed.
And so early on, when you were kind of first describing the company, you mentioned that some of the existing solutions or approaches that are being taken in the industry historically will take a long time. And my kind of understanding, and it's certainly not as detailed as you, is that one of the challenges with kind of doing layer by layer analysis is that there's a lot of layers, and that's a lot of data that you have to deal with. If you imagine a DM build or something, that it could be a terabyte of data that you have at the end of each build, and how do you effectively handle open transfer before getting to be able to use that information in an actionable way? Like, how do you kind of, I guess it's a couple questions wrapped in one, but kind of what are your thoughts on that?
So I'll tell you this. One reason I started this company was a lot of people were not using just pure optical layer by layer. They were going down deep into, or people still are, and that's a valid research. I'm not saying it's not, because that can be very useful, but people are looking into melt pool. Melt pool is great. You can look into it, but I have done melt pool modeling of welding, which is a much slower process than, laser moving at more than a meter per second, or sometimes, it's pretty fast. And monitoring such a small weld and spatter is a tough task. And you're generating a lot of data, and you're saying terabytes of data. Yes, if you're doing melt pool monitoring, and an inch of build could be a terabyte of data, which is huge. And if you're not providing value and notifications to a user, it's actually a burden to them. So that's one thing. Is we said we'll go after layer by layer monitoring. We'll monitor everything at a layer level rather than, layer means once a layer is done at that level, rather than millisecond level or microsecond level. So that reduces the amount of data collected, and also gives you time to analyze the data and give out results pretty quick. So still it's a lot of data. For example, with our system, a 3-day build will be 30, 40 gigabytes of data, right? So yes, that's a lot of data. If you have 10 machines and they're working, pretty much all the time, which you wanted to, then you're generating terabytes of data per year. So what do you do with that? What we actually have done is we have come up with a unique compression algorithm, which takes these layer by layer data and compresses it by 90%. So let's say after you made a build, you looked at the results, everything is good. After 10 days or 15 days, you're probably not going to go back look at the data. And then you click decompress, or it can automatically start decompressing. It takes click compress, and it starts compressing. And in a few minutes, it's compressed and reduced by 90. So your 30 gigs become 3 gigs. And that's a huge, huge positive aspect for this industry. So that is another innovation that we have. We haven't patented it. We are keeping that trade secret right now, but I think that can be a huge help as well.
And you said you're also doing FDM. What are some of the different kind of challenges that you see in the FDM space versus the metal space where you started?
Yeah, so FDM space is different in terms of FDM. There's some things happening, like you need different kinds of hardware. One is you cannot put an expensive, $1,000, $2,000 camera on a $20,000 machine, because then it becomes 10% of the cost of the machine, right? And then, so how can we use lesser expensive cameras and lesser expensive hardware, but still high resolution cameras to get our get good quality predictions? The other is else can we do in terms of what to detect defects in FDM. Your nozzle head is in the way. So if you're taking a picture from the top, it's difficult to do that. So what else can you do with a horizontal angle or different kinds of angle? Those are the issues. And then obviously the defects are different types, right? You have stranding or spaghetti formation. You have other things like, like nozzle clogging, which is totally different than what could happen in DMLS type of process. So those are challenges, but we are addressing them one at a time. Overall, the commonality is that platform is there, notifications are there. We are, the dashboard is similar. So we can leverage a lot of what we have already developed for DMLS to FDM. The AI algorithm changes for sure, but other things stay in place.
And you mentioned before that you did a lot of work in kind of traditional welding and kind of industrial manufacturing that wasn't 3D printing focus. As you've kind of transitioned to the industry and started to learn some of or kind of dove kind of straight into the deep end of the technology, what are some of your kind of more general high level observations of how the 3D printing industry as a whole is moving forward, and what are the challenges ahead?
3D printing, the biggest challenge is it's obviously still very nascent industry, and the processes, there's so many new processes, right? People are doing so much new research. Every day you look, there are new processes or variations of processes out there. So there are a few things out there, right? Some of processes are similar, and also new companies come out. Actually, one thing I've noticed in the industry is the companies, the equipment makers or the machine makers, they start off with very closed system, and that actually is not good for the industry and difficult for adoption. One is, whenever a new system comes out, universities want to buy it to do research on it. And if you have a closed system, universities have a tough time extracting data and doing research. So, you are actually hampering yourself. The other is, even when a user buys it, early adopters are going to be very well educated, like masters, PhD level people running machines. In the long run, yes, technicians will run it. But when people who understand the process very well, if it's open and can help them make changes, it actually helps the industry as well as helps the process. So I think the way new machine makers, if they start entering the market slightly differently, especially for the new processes, I think that'll help those processes, those companies, as well as the whole industry more. But the speed of adoption is amazing, right? It's just growing leaps and bounds every day, even on every month or every year.
Absolutely. Yeah. It's every day you read something new technology, new material that comes out of the market. Yeah.
And you are doing a lot of consulting in this area, so I'm sure you see even a lot more than I do.
And I guess kind of diving a little bit deeper onto that point. So do you see some of the traditional players, the big players in the industry, being more closed and the new ones more open, or is it kind of a transition? Any specifics on kind of challenges that you've seen between DMLS or FDM or technologies within the platforms of being able to work within platforms?
DMLS, DMLS, FDM is obviously a lot more mature, right? Because it's been around for a lot longer, and polymers are a little bit easy and to handle, and lower temperatures also help sometimes, right? So yeah, it's and then FDM is there are a lot of companies producing different kinds of machine and different levels of machine. So like I have a $300 FDM printer at home, but I can't put industrial parts on it. And but you can buy a $100,000, $150,000 FDM printer as well to print very good parts. So it's amazing to me that the same technology has such a wide variation and such a wide adoption. One thing, negative thing comes out of that is a person who's not involved with the industry does not know what an FDM, a high quality FDM is as compared to low quality FDM, and it all becomes all based on their 1 or 2 time experience. But comparing, it's I don't know if it's fair to compare different processes within additive manufacturing, because they're at a different stage and addressing different materials and would be used for different types of parts. So it's tough to compare, but DMLS obviously on metal side, DMLS is one of the more mature processes than any other ones, right? Or at least popular ones. So cold spray people might come and challenge me saying, hey, that is the best. But DMLS people might come back and say, no, that is better. But it depends which metal it is, which part you're making, what is the part's going to be used for, and things like that.
And kind of as a small business owner, entrepreneur, what advice would you give people who are kind of starting their journey along kind of both additive manufacturing, but maybe more generally in terms of starting a company with an idea in a growing industry?
Yeah, I think this is my technically a third startup. My first one I killed pretty quickly, realizing it's not going to be a huge company. I could have made it into a services company, or I would have made apps for people, but I decided not to do that. But so as a startup, you have to be able to, be really involved with that. You really think that's going to help the industry. If you're doing just to say, okay, I'm going to just doing this to make money, that may not work out in the long run, because most of the startups fail, just statistically speaking, and and a lot of ideas don't pan out. So another thing is, be ready to switch, keep your eyes and ears open, and be ready to work hard. So and if it's just purely for money, then it's going to be difficult ride.
Right. And so going in, we're kind of at the start of 2021. 2020 was an interesting year for everybody. What are you excited about and looking forward to in the year ahead?
Yeah, I think things hopefully will start picking up, and overall, it's all good. I think it's obviously additive manufacturing wise, additive manufacturing has got a lot of positive publicity because of being able to make PPE and being able to make face shields and other things. Especially America Mix did a really fantastic job in working with NIH and other things, face masks and other things as well. So a lot of good positive publicity. So definitely more knowledge is out there with people that this process exists and can be very useful. And various companies and government agencies have realized it's supply chain wise, this is an amazing process. Let's figure out what to do with it. So there is a huge positive push. There was a huge positive push and huge growth prior to this, but it's even probably going to be the rate of growth will be higher. So that is exciting. From our company standpoint, definitely, we are seeing a lot of interest from process monitoring standpoint. And as I mentioned before, we are getting a lot of good pull from the market. So we are excited about it and see where it takes us in the, Q2 and Q3.
Fantastic. And we were talking a little bit off air that maybe we'll see each other at AMUG down in Florida in May. So knock on wood.
Yeah,
hopefully things progress in that direction. So SK, I appreciate your time today, and best of luck in the coming weeks and months ahead.